This is how to find the domain of a rational function. That is a more specific term for functions that look like f. And we'll get more into what a rational function is later on in the semester, but for right now, it's this guy. So the problem with a rational function, and consequently the problem with f, is that the denominator is not allowed to be 0. So if I have, for example, like 10 over 0, this is going to cause a problem. This is going to give me a divide by 0 error. This cannot be done. So what this is basically saying is if I plug in a number for x and it causes that denominator to be 0, that number, I am not allowed to plug it in. That number is not part of the domain. So what I'm going to do is I'm going to take this denominator and say, all right, you are not allowed to be 0. And now I need to solve this for x. The way that I solve this for x is I pretend that this not equal to symbol is an equals to, doesn't really matter, they function the same way in this context, and factor the left-hand side. So what I notice is that this term right here contains an x. In fact, it has 3 copies of x. And this term right here also contains an x. So what I'm going to do is I'm going to take that x, pull it out to the front, and then one x gets removed from this guy, and one copy of x gets removed from this guy. One way that you can check to see that you're doing this right is if I multiply this back together, I should get what I started with. And real quick, we can see that if I do x times x squared, that will give me x cubed. And if I do x times 8, that is going to give me 8x. So this is the correct factoring. Okay, and once I have it factored like this, I essentially get multiple answers. For each factor, so in this case, that would be x, and then the parentheses is the other factor. For each factor, I have a separate equation. I have x does not equal 0 from this guy, and I have x squared plus 8 does not equal 0 from this guy. This is called a factor, this is called a factor, and I take each of them and I set them not equal to 0. In case you're wondering what this rule is called, this is called the zero product rule, if you want to do some more research on that. Okay, now what I need to do is solve each of these independently. So this guy right here is basically already solved. I know that I can't plug in 0 for x, but what about this guy? That one's not solved. So I'm going to go ahead and solve for x in the second question. All right, I'm going to move the 8 over to the other side, so I'm going to have x squared does not equal negative 8. And now the way that I get rid of the square is by taking the square root of both sides. So I would say x does not equal the square root of negative 8. And if you want to be technical, there should be a plus and minus here. Now, this is not actually a result we care about. Why? Because you actually can't square root a negative for right now. When you do that, you'll get imaginary numbers, and for right now, we're working over the real numbers. So for our purposes, this is actually kind of useless information. This didn't give us any numbers that we can't plug in yet. If we're talking about imaginary or complex numbers, then this will become important. But for right now, it didn't actually matter. So the only number we can't plug in for x is 0. So my domain is everything except 0. The way that we write this in math notation would be 2 ways. I'm going to say I need x such that x does not equal 0. This could be set notation. So I'll write that over here, set notation, and interval notation. What I want to say is everything from negative infinity up to 0, that works. And I want to glue it together with everything that's from 0 onwards. Basically, what I'm saying is this is like negative 0.000001. And this is like 0.00001. I can get very, very close to 0, but not quite. 0 itself does not work. Okay, so this is how you find the domain of a rational function.